Okay, guys, what we're doing today is a continuation of what we started earlier this week. If we were in class, we would have done all this in one day. I kind of chopped this up into 2 different days so that you could see it in 2 parts. The important thing that we looked at, one important thing we looked at is we talked about average value. And remember what we were really trying to do with average value was to try to essentially make a rectangle where the area of that rectangle was exactly the same as the area under the curve. So in other words, that blue rectangle would have the same area as the red area under the curve. So those should be the same. And from that, we said that average value, that y value, we called f of c. What the theorem is really saying is, remember, f of c is a y value. That x value is called c. And what the theorem really says is if it's a continuous function, c is guaranteed to be over this interval. In other words, c is guaranteed to exist between a and b. And there's at least one place. There could be multiple values for c, but there's at least one. You may say, well, Mr. Ashby, how could there be multiple values? Well, if you think about, you could have something like a parabola, and so you might have a C here and a C there if you're trying to draw a rectangle that was the same as the area under the curve. So anyway, you could have more than one C. There's only one average value, but you could have more than one C. Remember, the formula for finding average value was f of c equals 1 over b minus a times the integral from a to b of f of x dx. And that is still the same. What we did Monday is essentially step one, okay? So I've written out a very simple step-by-step guide here to help you solve this. And I'm using the exact same examples that I did on Monday so that we wouldn't have to totally redo all this over again, although for the first example, I'm going to walk you through it step by step the whole way. So let's look at our steps here to solve for C. Step one, we find the average value, just as we did earlier in the week, just as you did on the worksheet. If you don't understand that, you've got to know that before you take the next 2 steps, because without knowing how to do step one, the rest of this you'll get wrong. Step two, you set that value, that average value, the number that you found in step one, you set that equal to the function using C as the variable. And then step three, you solve that. Now I'm going to show you how to solve that using your calculator. Some of these you could solve using algebra. So let's look at this first example. It should look familiar. It's exactly the same one that you did the other day. Now, what we did the other day is we said, okay, if I want to find the average value, right, so this is step one, the average value, f of c, is going to equal 1 over 4 minus 1 times the integral from 1 to 4 of 2x cubed dx. We could do this in our calculator. That was 1/3, and then we did this as math 9. And when we worked all this out, we got an average value of 42.5. That is what we got. So far, so good. This is exactly what we've done. There is no difference. Step two today, step two, we take that value, 42.5, and we set it equal to that function. The only thing we change about that function is instead of calling it x, we're going to change x to c. At this point, guys, that's step two. Step two is done. We literally just set this value over here equal to that function. Step three is the heart of what we're trying to do, and the heart of what we're trying to do is we're trying to solve for c. Now, if I am doing this, using some traditional mathematics, I'll do 42.5. I'll divide both sides by 2. That'll be 21.25 equals c cubed. And then, so this is step 3 here. And then I would take the cube root of both sides. And so the cube root of 21.25, which is 2.7698, that would be my c value. Now here's what's important. This value will be between those two numbers. So sometimes you'll get extraneous solutions, but you're guaranteed to get at least one solution that falls over the intervals. So 2.76 is definitely between 1 and 4. There are alternative ways of solving this. I'm going to show you in the calculator video how to solve this using a calculator. So let me tell you how you would solve this using a calculator. We're trying to figure out where 42.5 equals 2c to the third power. You could do this one of two ways. Graph this into y1, graph this into y2, and literally see where they intersect on your graph. Now, because that's such a big number, you might have to zoom out, or you might have to change your window, but you could literally graph this function, and then just use the intersect to see where they intersect. The other thing you could do is if you have 42.5 equals 2c cubed, is you could subtract 42.5 from both sides. And now, instead of looking for where they intersect, you would just see where this crosses the x-axis. And where that crosses the x-axis would give you the same value. So look at the calculator video to follow up, and you'll see how I get that solution for both of these. Now guys, to abbreviate this video a little bit, I'm using the same examples as last week, or not last week, earlier this week. And if you looked at what we did the formula earlier this week, we got that the average value equaled 13. So if it's a brand new, fresh problem, unfortunately, you have to use the formula and start from scratch to get that value. But when we did this earlier in the week, we got that this had an average value of 13. So that was step one, right? Step one we did on Monday in Monday's notes. Step two, I'm literally going to take 13 and I'm going to set that equal to 6 times the square root of c. I just change x to c. At this point, I'll divide both sides by 6. 13 over 6 equals the square root of c. And then I'll square both sides. C equals 13/6 squared. And if you do 13/6 squared, you get 4.694. Does that fall on my interval? It sure does. Watch the calculator video because I'm going to show you in the calculator video how we would solve this. Again, we would either graph these independently and see where they intersect, or I would see where 6 times the square root of x minus 13 crosses the x-axis. For example 3, guys, we solved this the other day. In step 1, we said the average value for this one was 5 1/3. I'm going to write that as 16/3 just to kind of help us see what this looks like. So in step 2, I'm literally going to set 16/3 equal to x squared plus 4, and now the goal would be to solve for x. In your calculator, you could graph these separately, and when you graph those separately, you would see where they intersect, or you could get everything to one side, set equal to 0, see where it crosses the x-axis. I'm going to solve this by hand. So what I'm going to do is I'm going to subtract 4 from both sides. Subtracting 4 is like subtracting 12/3, so I'll be left with 4/3 equals x squared, and then I'll take the square root of both sides. So it'll take the square root of both sides. That'll be the positive or negative square root of 4/3 equals x. Now, when I put that in my calculator, that's going to be 1.155. X equals positive or negative 1.155. Well, I've got 2 solutions this time, so let me go back here and see if it works. Do both of those fall between -2 and 2? They sure do. Both of them actually do. So I have 2 solutions here, which is to say that C either equals 1.155 or C equals negative 1.155. C and X are the same thing. I know this time I didn't really change that to a C, but C and X are the same thing, essentially. Okay, guys, for this one the other day, I found that the average value was 2 divided by pi. So in step 2, I'm going to say 2 divided by pi equals the sine of C. Well, there's a couple ways to do this. Again, graph these independently in your calculator, see where they intersect. You could subtract 2 over pi to get everything on one side and get the other side equal to 0 and see where it crosses the x-axis in your calculator. For this one, being in radian mode, make sure you're in radian mode. If I want to get c by itself, I'd have to take the inverse sine of that side. So I do the inverse sine of 2 over pi. Now this, a lot of times with trig, this won't always give you all of the answers. So you kind of want to make sure that you do it on this one on your calculator. But if we do that, we'll get 0.6901. Since pi over 2 is basically 1.57, I kind of confirm that this value will be between 0 and 1.57. So those are my values. Good luck today, guys. Please let me know if you understand this. We're taking a quiz on this on Monday. So you've got today to learn this, tomorrow to practice, and Friday to ask questions before we take that quiz. Hope you have a great day.